Hi, everyone. Thanks for tuning into my talk. I hope you've been enjoying the conference so far today. My name is Breanna, and I'm going to be presenting on some research that I've been doing with my supervisors, Eric Oliver and Claudio Porta, on Inuit knowledge of ocean conditions, trends, and changes in coastal Nunatsiavut. And this was done in collaboration with community members from Riglet and Hopedale, as well as the Nunatsiavut government. So to start with a little bit of context and motivation, as we all know, the effects of climate change and other anthropogenic stressors are increasingly impacting Arctic and subarctic communities located throughout Inuit Nunavut, which is the Inuit homeland encompassed by the Inuvialuit settlement region, Nunavut, Nunavik, and Nunatsiavut. And because of these ongoing impacts, there's a drive for research that can inform future adaptation and planning at regional and local scales. And this is true for Nunatsiavut, which is where this research is taking place, and which is an Inuit self-governing region in northern Labrador, where an increased understanding of oceanographic variables can support ongoing policy development and planning for future change in the area. And in addition to the value of having a strong oceanographic observing campaign, Inuit are ocean experts, and their knowledge offers insights of locally important features and processes. And so documenting Inuit knowledge can contribute to our understanding of local climate change impacts and inform future oceanographic research in the region that reflects local, spatial, and temporal scales, as well as community values. And so to give you a little bit of background, this research took place as a part of the community-based observing of Nunatsiavut coastal ocean circulation, so the CONOC project, which was initiated in 2018 and is motivated to understand ocean circulation and how it could be changing in order to predict things like how Inuit winter travel routes and harvesting may be impacted in the future. And the project draws from a community-based monitoring program where community members help identify areas for data collection and assist with the data collection itself. And the other aspect of the project is what I was involved with, which aims to document Inuit knowledge of oceanographic features, trends, and changes through participatory mapping and interviews. And so in 2019, two communities, Riglet and Hopedale, indicated by the black boxes on the map here, were visited to host participatory mapping sessions and interviews to document Inuit knowledge of oceanographic features in the regions. And so before I jump into the methods, I wanted to give you a brief overview of what I'm speaking about when I refer to Inuit knowledge. So the Inuit Circumpolar Council defines Inuit knowledge as a systematic way of thinking applied to phenomenon across biological, physical, cultural, and spiritual systems. And it includes insights based on evidence acquired through direct and long-term experiences and extensive and multi-generational observations and lessons and skills. And it is developed over millennia and is still developing in a living process, including knowledge acquired today and in the future. And it's passed on from generation to generation. And so when I'm speaking about Inuit knowledge, in the context of Nunatsiavut as well, it's very place-based and highly contextualized. And it's derived from these human and non-human relations. And so in the case of Inuit ocean knowledge, it's reflective of kind of how, when, and why people are on the ice and ocean, what they're experiencing, and how they respond as well. And so how do you document this? We followed the guidance of some other successful methods throughout Inuit Nunavut and looked to participatory mapping, which typically is done in resource harvesting kind of studies. And so we wanted to try it out for oceanographic features. And so we held group sessions in both Riglet and Hopedale and used these really large floor maps, laying one down for the open water season and one for the sea ice season. And people mapped things like boat and sled travel routes used in the open water and sea ice season, as well as sea ice features such as areas of open water, unsafe ice, and the typical ice edge, as well as ocean currents, indicating if they were weak, medium, strong, or very strong. And after these mapping sessions, we held semi-structured interviews to capture more detailed descriptions, which allowed us to contextualize what had been marked on the maps. We were quite interested about change over time, which was documented on the maps in Riglet and spoken about in both communities as well. And so for the purpose of this talk, I'm going to be focusing mainly on the results from Riglet, as you can see here in this map. And so everything that you see here was documented by community members. This area in Grosswater Bay remains open water year round, as does this region here in Doublemere, indicated by the blue. What's not on the legend are these ocean currents indicated by the blue lines, which are quite strong here in the Narrows, contributing to the open water remaining year round. And the area is also known for having ice that's not considered to be safe enough to travel over. And so these gray areas indicate regions that would freeze over in the winter, but people wouldn't feel confident to travel over using their sleds. And then, of course, the orange and the green lines throughout are the travel routes. So the orange are the boat travel routes, and then the green are the sled travel routes. And so Riglet is not actually accessible by road, and so travel over the land, water, and ice is essential for people living in the community. And so one area that I didn't go into, which I am to now, is this area here, locally known as Pelter's Island, which experienced quite significant changes to the sea ice conditions after the Churchill Falls hydroelectric dam development took place in the 1970s. So prior to the 1970s, this area was known to be areas of open water. And you can kind of see how the travel routes interact with that, passing through the islands around the areas of open water, which potentially would have been used as hunting areas in the wintertime, and are quite important for traveling to and from the region to know these areas. And then after the dam was put in place and the outflow of the Churchill River significantly changed, these areas no longer were open water and instead became known as unsafe ice. So they'd actually freeze over, and people expressed a lot of shock at this having happened, having never seen this in their lifetimes and never heard of that being frozen over before. And so this change in ice conditions was associated with increased salt water in the areas like Lake Melville, which again used to be dominated by freshwater outflow from the Churchill River. And so as one participant described, this increased salt water made a lot of difference to the Lake Melville area. It made a lot of difference to the ice too. Like now, Lake Melville used to be all fresh water one time, just about all fresh, and now it's salt right up. Like up to Mulligan one time, you could go down and dip up water anytime and drink it, fresh water. Now it's just as salty as out here, referring to the ocean where Riglet is located. And so what's quite important in documenting these changes is how Inuit knowledge came to be represented on the maps, which are a fairly static form of representing such a dynamic relational knowledge. And so thinking about things like seasonality, of course, is really important when talking about sea ice features, but also the mobility routes. And so as I mentioned, these really indicate how people interact with those features, helping to contextualize that knowledge as an important thoroughfare and potential hunting area, and showing really how all of these features relate to one another. So this kind of collective relational data demonstrates the way that Inuit would be interacting with marine spaces. And this is kind of all encompassed in people's stories, like the quote I included here, which just kind of offers another window of understanding into how these oceanographic changes were experienced. And so when documenting Inuit knowledge in such a way like mapping, it's really important to account for the holistic understandings that have shaped that knowledge, as was indicated in the description that I included at the start of my talk, which is quite distinct from the way that Western scientific approaches generate understandings and knowledge. And so in doing so, we're suggesting that characteristics such as seasonality, mobility, relationality, and narratives are really important to document alongside the oceanographic features to really help contextualize that data. And this approach can allow research to be situated at a scale that's relevant for communities and respectful of the tangible and intangible ways that Inuit are connected to marine spaces. And so what we've done, or what Eric has done with this knowledge, is used it to test a numerical ocean ice model, which was developed for the Riglet region, where predictions were made related to the fast ice conditions as well as the current speed, including the change that occurred after the Churchill Falls development took place that I just described. And so Inuit knowledge was used to help validate the predictions. And in this case, this was done visually. So you're seeing the Inuit knowledge of ice conditions here in comparison to the probability of fast ice here. And so we see pretty good agreement between the simulated currents and documented Inuit knowledge of currents in the region. And the sea ice predictions also saw general agreement as well. And so while I can't speak to the technicality of the model itself beyond just the comparisons that I included, what I'd like to explore here is the role that the maps were able to play in mobilizing Inuit knowledge into this application, and where and how those characteristics played a role in this mobilization. And so seasonality, of course, was important for sea ice characteristics and in defining the model parameters. And then relationality demonstrates almost a weighting of how participating individuals value certain spatial features. So where you see concentrated spatial data, including mobility routes, where people were hunting, traveling, or fishing, this kind of helps show where there's a more common concentration of people to be in these marine spaces, and where model predictions are more likely to be validated against that knowledge as well. So kind of where you're seeing this overlap take place. Of course, there's still challenges to this process. So for example, there was a lot of knowledge that was shared during the mapping session, but that wasn't spatially rendered. So for example, people spoke about the reduction in current speed after the Churchill Falls development, but because this wasn't mapped, we can't actually use it to validate the model predictions. At the same time, having these narrative type explanations enable us to look at the model predictions and contextualize that in relation to the knowledge that was shared during the mapping session. And so just to wrap up with some conclusions, Inuit knowledge of oceanographic features supports an area that's deficient in data while identifying features of relevance to community members. And Inuit knowledge and the context of that knowledge can really contribute to and potentially guide future oceanographic research in the region. But in documenting Inuit knowledge, accounting for context is essential. And with that, I'd like to say thank you so much for your attention, and I hope you enjoy the rest of the conference.